Hello friends, today I will discuss about why secondary of CT is kept always shorted. It should never be kept in open condition. Now what is the basic principle of the CT? The basic principle of the CT to reduce the current to a certain amount to get the input to the relay or ammeter or energy meter. For example, if a CT ratio is 1000/1, then if primary current flows in the 1000 ampere in the primary side, then 1 ampere will flow in the secondary side. That is, the CT ratio will be I2 by I1 equal to N1 plus N1 by N2, that is equal to 1 by 1000. In primary side, CT has a few turn or a single turn. For this example, if the CT ratio is 1000/1, then if the primary has 1 turn, then secondary will have 1000 number of turn. This is the basic principle of the current transformer. Now, how does the current transformer work? The core of the current transformer has been shown in this diagram. Here primary current, that is IP, flows in the primary side of the winding. Primary side of the winding has a single turn, and secondary has a number of turn depending upon the ratio of the transformer. IS is the secondary current which flows in the secondary side of the current transformer. Now if IP flows in the primary side of the winding, if number of turn in the primary side is N1, then IP, that is current in the primary side, will produce a MMF in the primary winding, and that is equal to N1 into IP. This MMF will produce a flux in the core, that is equal to phi. This flux will linkage to the secondary winding of the core. This secondary winding will produce induced a EMF depending upon the turn, that is E is equal to N into d phi by dt. Now number of turn is N2, that is induced EMF will be equal to N2 into d phi by dt. Now if the current transformer is connected to a load, that is ammeter or relay, this induced EMF will drive a current that is equal to IS, and due to flowing of the current, this current will this current will produce another flux, that is that will oppose the flux that initially was produced by the primary winding of the current transformer. Or we can say that is due to flowing of the current in the secondary side of the current transformer, an MMF will be produced in the secondary winding of the transformer, that is equal to N2 into IS, which is opposite of the MMF that was produced by the primary winding of the MMF. Therefore the net MMF or magnetic motive force is equal to N1 into IP minus N2 into IS. Therefore, since the reluctance is fixed, net flux will be equal to phi minus phi s, that is equal to net MMF by reluctance. Now due to flowing of the current in the IS in the secondary winding, a phi s will produced in the flux that will oppose the flux that was produced by the primary winding. Now net flux is phi minus phi s. This is the principle of the current transformer. Now somehow CT secondary is got open, then the net MMF produced by the primary winding is equal to N1 into IP, which will produce the flux only phi. This flux will flow in the core of the transformer, and this will induce an EMF depending upon the number of turn of the secondary winding. This EMF will be very large. Now, since there is no opposition, flux opposition, since there is no secondary current in the secondary winding of the current transformer. Now, due to this large induced EMF, insulation failure of the secondary winding may occur. Also, if a person somehow get touch this secondary winding or somehow touch the open circuit of the secondary winding by screwdriver, he may got electrocuted due to high voltage develop in the open circuit. Now consider the secondary is open and at the same time a fault is occur. During normal condition, the rated current or load current will flow in the primary side of the transformer. This will lead to flow large amount flux in the core of the current transformer. But during fault, this current will be much more during the normal condition. Due to this, a huge amount of flux will flow in the current transformer core, and that will lead to saturate of the current transformer, and therefore the eddy current loss and hysteresis current loss will be very high in the core. And as the CT is oil filled, because of overheating, the oil of the CT will get boiled and start to vaporize, and it will pressurize the upper tank of the current transformer. Because of vaporization of the CT oil, the CT housing will get pressurized and it may lead to blast of the current transformer, and also may lead to fire if the oil in the CT get the flash point of the transformer oil. In this image, a 220 kV CT of ratio 800 by 1 has been shown, which catch fire due to fault. Now, after visual inspection, it has been found that one of the core of the current transformer was open. Therefore, we can conclude that due to open of the CT core, during the fault condition, as the current in the primary winding was very high, the core was saturated due to huge amount of flux, and due to this, core get overheated. Also, the transformer oil in the core get the flash point of the transformer oil, and due to this, the fire catches in the CT. So, the secondary of the current transformer should never be kept open, and always a visual inspection should done, so that the secondary should never be got open. Friends, if you like my videos, and then do subscribe my channel and also press bell button for notification of videos to be uploaded in future. Thank you.